Okay, today we're going over CC1 1.2.4, Part 2, Review and Preview. This is a continuation from Part 1. So problem 90 says to write a whole number in the box for the fraction that makes it equal to 1, greater than 1, less than 1, equal to 0, greater than 100. So what we mean by the box is we need a numerator for each of these fractions. So for part A, it needs to be equal to 1. Well, we talked in class, anything that's equal to 1 has the same numerator and the same denominator. So it has to be 4. B is greater than 1. So if 4 makes it 1, then anything 5 or larger will make it greater than 1. For less than 1, needs to be less than 4, right? So it could be 3/4, it could be 2/4, it could be 1/4, it could be 0/4. Those are all less than 1. For part D, we want to make it equal to 0, which means that we don't have any parts. For part E, we want to make it greater than 100. Now, our instinct is to say, okay, well, 100 over 4 is greater than 100. But really, it's not. We want to say, well, what would make it 100? So a number divided by 4 would equal 100. A number divided by 4 would equal 100. Well, if I think about this, 100 times 4 would get me that number. So 400 makes it 100. But I want it greater than 100. So I have to have 401 or larger. Okay. Problem number 91, we're looking at a dot pattern and sketching the fourth and fifth figures. Well, each time I have to figure out where it's adding the dots. There's one there and one there, and then one there and one there. It's adding 2 each time. So I'm going to start out with my pattern for figure 3. I'm going to add 2 more dots. Figure 5. I'm going to start with my pattern for figure 4. And add 2 more dots. That will give me figure 5. Okay, we need to figure out how many dots are going to be in the 50th figure. So if I add 2 each time, okay, and I can say, well, here's 2 dots here. So if I had a figure 0, I would just have these 2 dots. So I add 2 each time. So 50 times 2 is 100. And then I have to add these 2 original dots. So 100 plus 2 is 102 dots. Problem 92, we learned about prime factorization in class. So we want to take 24 and figure out, well, what times what is 24? 6 times 4 is 24. You could put 8 times 3 or 2 times 12. It'll still get you to the same answer. 6 is not prime, so I have to keep going until they're prime. Well, 6 breaks down into 2 times 3. 2 and 3 are both prime. 4 breaks down to 4 times 4, or not, so I'm sorry. 2 times 2. Those are both prime. I want to write my answer on this line. 2 times 2 times 2 times 3. But in class today, we talked about exponents, and I want to rewrite it using exponents. Well, there are 3 2's, so my exponent is 3 because there's 3 of the 2's, and I have 1 3. problem 52, or part B, we're looking at number 52. And I might not know off the bat what goes into 52, but I know that 2 does, because 52 is even. So 52 divided by 2, okay? And if I don't know it, I can always do my long division, right? Or use a calculator. 2 goes into 5 2 times, which leaves 1. I drop down my 2. 2 times 6 is 12. And that's my answer. So 2 times 26 is 52. 2 is prime. 26 is not. Again, it's a prime number or an even number. 2 goes into it. 2 goes into it 13 times. 2 is prime, 13 is prime. So I'd write 2 times 2 times 13. If I'm using exponents, it would be 2 squared times 13. Okay, 105. It ends with a 5, so based off of our multiplication chart patterns, 5 will go into it. 5 goes into 120 times, so 5 should go into 105 21 times. 5 is prime. 21 is 7 times 3. 7 is prime and 3 is prime. So below it, I'm going to write 3 times 5 times 7. I can't simplify using exponents, so that just stays there. Okay. Problem 93. We need to round the decimals to specified place values. So if I'm looking at my hundredths place value, I find my hundredths. So I have my decimal point, and my tenths and my hundredths is the 9. I look to the 3. When I round, it's 17. The 3 tells me the 9 stays the same, and everything else turns to a 0. Part B, I'm rounding to my thousandths place value. So I have my 0 and my decimal. Okay. Then tenths, hundredths, thousandths is my 0. I look to the 2. The 2 tells me the 0 stays the same. So I write everything that comes before my underlined number. My 0 stays the same. Everything behind it turns to a 0. Part C, I'm rounding to the 10th place value. My 10th place value is the one next to my decimal. I look to my 5. My 5 says that my 2 needs to change to a 3, my underlined number. So my rounded number to the nearest tenth is 8 3/10. Everything else turns to a 0. Part D, I'm comparing. So an easy way to do this is to make sure that they have the same number of digits before and after the decimal. (47 2/10) would be 47 200 thousandths, which is greater than 47 197 thousandths. Okay, part E. I can look at the number of zeros. This one has 2. This one has 3. Since there are more zeros on the right side, this first one, 1 and 32 10,000ths, is greater than. For part F, I have 0.0089 89 10,000ths and 0 and 300ths, but I want to make sure I have my place values the same. I have the same digits on each side. Well, 0 and 310 thousandths is bigger than 0 and 89 10 thousandths. Problem 94, we're simplifying the expressions and then answering questions. So part A, 13 times 1. Well, 13. 1 times 5 and a half, 5 and a half. 6 times 1/2, that is the same as dividing it by 2. 6 times 1/2 is 3. 12 times 2 is 24. 4 times 3 over 3. Well, 3 over 3 equals 1, so it's the same thing as multiplying by 1. So the answer is 4. 14 times 1/7 is the same as dividing 14 by 7, which is 2. There are 14 divided by 7 is 2. So part G asks us what happens when you multiply a number by 1. Well, the number stays the same. In part B, it asks, what if it's a number less than 1? Well, my fractions that I multiplied by, the number got smaller. And if I multiply by a positive number greater than 1, like in part D, and, well, I think that's the only one that multiplied by a number greater than 1, the number got larger. As always, if you need help on homework, please feel free to come and talk to me.